Let's solve problem 45 on page 101. Here's a problem. Oh gosh, let's focus that, huh? It says, the coefficient of kinetic friction for a 22 kilogram bobsled on a track is 0.1. What force is required to push it down a 6-degree incline and achieve a speed of 60 kilometers per hour at the end of 75 meters? 75 meters. I don't think they run that far. It seems like this is not a very realistic problem, but that's okay. Oh, what was the mass of the bobsled? I forgot to write that down. 22 kilograms. And 6 degrees, very slight incline. Well, we're trying to, so let's try to find this force. So let's use the procedure. I'm just going to draw the bobsled as a little rectangle thing. It's easier. And so we've got gravity. We've got a normal force. We've got the normal component of gravity. Oh, I'm getting ahead of myself. We've got a pushing force. And I got a little bit of friction. And then this gravity has mg cosine theta and mg sine theta. And let's make down the incline positive x, positive y. So I think you can see I'm using the procedure here. Step 1, given, find, and solve. Step 2, I drew a free body diagram. Identified my x and y direction. This is mg cosine theta, right? Because here's our angle of incline right here, 6 degrees. Now I'm going to sum the forces in the x direction equals ma in the x direction. So I'm already into step 4. Sum the forces in the y direction equals ma in the y direction. Well, in the x direction, what have I got? Well, I got this mg sine theta. This is the component of the weight that's pulling it down the incline. Plus the pushing force minus the force of friction equals ma. Sorry I'm writing this so small for you in the back. Come on up front if you want to. Well, let's do this. Sum the forces in the y direction equals, oh, I already did that. So I've got the normal force minus mg cosine theta, right, this part. Those are the only forces in the y direction. They equal 0. There's no acceleration perpendicular to the plane. So we know the normal force is equal to mg cosine theta. Now, here's what I need to do to solve for this. This is what I want to solve for, so I'll go ahead and do that. This pulling force is equal to ma plus the force of friction minus mg sine theta. You see what I did to go from here to here? I just solved for my unknown. That's really, I'm into step 5. Now this tells me what I need. Do I know the mass? Yep. Yes. Do I know g? Yes. Do I know the angle? Yes. Do I know the force of friction? No. Let's figure out what the force of friction is. Mu times the normal force. Well, mu is given to be 0.1. What's the normal force? Mg sine theta. So, let's see, m is 22 kilograms times g is 9.8 newtons per kilogram. And what is sine theta? Or cosine theta, I'm sorry. It's mg cosine theta, the cosine of 6 degrees. And it'll take about 3 or 4 more minutes, so if you want to stay, you can stay. So let's clear this. 0.1 times 22 times 9.8 times the cosine of 6.
Juniors and seniors, this is a reminder that there is a library lecture
Oh, good.
hall right now. There's a lunchtime counter class informational meeting in the library lecture hall now for juniors and seniors interested in counter class.
So I got 21.4 newtons for the force of friction. We also need to figure out, so we got that now. We don't know what the acceleration is. That's not given. But I'm given the initial velocity, well, it was at rest, v naught equals 0. So I can say, well, v final equals v initial plus acceleration times time. So I can solve, or wait, what do I want? I don't know the time. Oh, can't use that one. What's the one that doesn't have time in it? That's the one that we'll use. To a delta x. Because we know, yeah, now we know everything. So a is equal to, well, this is 0. So it's v squared over 2 delta x. Well, what is v? V is 60 kilometers per hour. 1 hour is 3,600 seconds. 1 kilometer is 1,000 meters. So 60 times 1,000 divided by 3,600, 16.7 meters per second. So I can say A is equal to, well, 16.67 actually, we'll round it a little better, divided by 2 times 75 meters. So yeah, this is a long problem. So squared divided by 2 divided by 75. So I get an acceleration of 1.85 meters per second. Now I can plug that in there. So the pulling force is equal to the mass, 22 kilograms, times the acceleration, plus the force of friction, minus mg times the sine of 6 degrees. So let's do that. See, 22 times 1.85 equals 40.7 plus 21.4. That's 62.1. And then we're going to subtract from that minus 22 times 9.8 times the sine of 6 degrees. And I get a pulling force of 39.6.
Can we just round that to 40?
Yeah, around 40. Now, I'm going to check this in the back of the book. I'm going to be very, very sad if this is wrong.
That's right.
40, yeah, 40 newtons. So, victory over another physics problem. That is all.
So that's going to be